Okay, let's do the Gemini symbol. So same deal as usual. So we're going to open up the main file, make a section for that particular symbol, and then work from there. Right? So we'll keep something open for what this needs to look like. So Gemini is kind of like 2 slashes and then a very big circular curve, basically. So with that, that shouldn't be too hard to make. We'll make a section. Let's close this for now. I mean, actually, we could just get this out of the way now, right? So let's just copy this part, copy, paste, and we'll call this Gemini code for the cutting sheets. And the Gemini code should just be, instead of component Taurus, right, it's going to be component Gemini. And obviously this is a lot of, what would you say? It's a lot of bloat, where it's like, this is a lot of cut-paste code, it's a lot of redundancy. But the other thing is it's dead simple. It's dead simple, right? So, and I don't know how we might want to change this in the future anyways. So before we try to refactor it into some type of common function, we might want to make sure that we're absolutely certain on that, right? Okay, so now that we have this kind of thing in here, Gem1, Gem2, cutting sheet code, this actually needs to be changed as well. So anywhere we see Taurus, it needs to be changed to Gemini, right? So Gemini, right? And if we keep the code consistent, then we don't have to even reference that. We'll know exactly what we're making when we make it, right? So let's create Gemini code. Okay, and in here, we're going to, let's just make sure we can hear ourselves here. Yes, we can. Our bitrate is kind of suspect. But yeah, we'll put that in there as well. And module, okay, Zodiac table component, Gemini, takes a SBC object, which stands for shopbot constants. And inside here is where we need to start doing the work. So since this is where we're going to start doing the work, we're going to throw this in here, right here, with the actual object. And then the wheel frame isn't supposed to be embedded into the code, is it? So let's go look at the cutting sheet for a second. In the cutting sheet, the wheel frame and the Gemini, they are separate things, right? So the wheel frame, yeah, they're all supposed to be separate. So this Taurus thing, we gotta remove this wheel frame code, right? So nowhere else is it referenced, right? Is it? Yeah. Yeah, I mean, it's right there. But yeah, it's not supposed to be used directly in here, right? That was probably just to get things working. But right now, let's just put them, you know, both up here. Because we do want to see that wheel frame as we're designing, because we need these symbols to kind of fit nicely within there. But we don't actually want that code right out in the embedded into the function. So let's go top view, view all, render, blah, blah, blah. Okay, so we got this kind of base thing, right, to work with. That's the wheel frame. We want to make sure that the Zodiac symbol kind of fits within there nicely. So we're thinking some type of curved line thing, and then we just kind of split it at some point. So what I'm thinking is, let's work on that curved line. And so we want to do a V-carve inch wheel, right? A V-carve inch wheel. And we use the SBC object. And then we need a radius, right? So for that, we have these kind of constants here. Let's just say we've been putting the newest stuff close to the top. I question if that's the way we want to do this. But you know what? Whatever. Let's not worry too much about it. If we really need to shuffle this around, we can. So within here, is there any patterns we can recognize? So we know we're going to call it Gemini, and then it's going to be like Imp Rad, right? There's only one radius when it comes to this, right? So let's give it like an 8. Or, yeah, let's give it an 8, because it's going to be pretty big. 8 inches. This is like a 5-inch area within here. Well, let's just do that for now, and then, that's all we need. That's all we need for now. And that imperial radius is going to go right in here. And the wheel actually has a thickness, right? So, but the thickness that we're going to use, right, the model constants, distance between locator holes, the thickness of a wheel, right? Or actually, not the thickness of a wheel, the thickness of a sign, right? So it's the same kind of thing, but we want the different thickness variable in case we decide the wheel and the zodiac signs need to have different thicknesses later. Okay, so that with that there, we know that this needs to have the radius, but then it needs the thickness of the sign. And give it a run and see if... Okay, so we got this big circle right way out there, right? And that's actually what we want, because now what we're going to do is we're going to... how are we going to create it? What's the easiest way to create it? I'm thinking we want to create a deletion area. I think we want to create a deletion area way up here and then just move this up, right, into the deletion area. And that's going to help. Yeah, let's just do that. So let's do a difference between this, which also is going to be moved up. So let's just say inch y, right, and takes a SBC object. And right now, I don't know, we'll move it up like 4 inches or something. We don't really care exactly what that is, right? So we're going to difference this circle. What did we do wrong here? Oh, because we didn't close off our difference. Okay, so with this, right, we have this kind of circle thing, whoa, way up there, and we're going to push it up until it's kind of like where it needs to be, but this doesn't really make much sense yet, but it will. So we need a deletion rectangle of some sort, so we're going to be like, it needs to be up there somewhere, so inch y, SBC, rec height, divided by 2. Rec height divided by 2. So we're going to uncenter the rectangle. And then rec up. How much does the rec go up? I don't know. And the rectangle height, rec height equals, I don't know how tall the rectangle needs to be. We could make it ridiculously big, though. We could make it very... if we look at this, it probably needs to be... we should probably make it the exact radius of... to make sure it can always delete all of this circle right here, we should make the rectangle height this radius, right? The imperial radius times 2. And then also add the thickness to it. And the thickness is on both, so plus the thickness. Okay. And then this rec up amount, I don't know how much it needs to go up. I guess for now, it could just be 0. And if that's correct, then we're going to see it get deleted. We're going to see this upper portion of the circle get deleted after it crosses the midline, right? After it crosses the x-axis. And if that isn't what the case is, then we need to reevaluate our life and wonder what the heck we're doing wrong. Well, the first thing we're doing wrong is we don't have any deletion rectangle, right? So We need a V-carve inch pocket, right? Because it's going to be a rectangle, and it's going to be SBC, and the width is going to be the rec width. It's going to be rec width, and then it has rec height, and there's not going to be any thickness applied to it. Okay, so with this rec height, what's the rec width, though? So rec width equals, it needs to be, probably needs to be the same thing, honestly. So let's just do rec san equals, and then let's steal this formula from over here, right, and paste that there. And then, right, so basically the width and height are equal. So sometimes they use a variable called san, which stands for span. And maybe that's, like, not a good idea to write it that way, but... Okay, so there we go. So it's divided right where we thought it was going to be divided. And so now the thing is to move it up, right? So this up amount, we're going to move it up somewhere wherever it seems to make sense. I don't know. So let's just try 3 for now. F4. And so we can see now it's like, it's way up here, right? And that's a little bit too far, actually. F4? Okay, so now we see it kind of up here, and we're really not going to be able to know exactly where that needs to be until we start pushing up the curve, right? So let's call this sur up. So sur up equals... Well, first we want to take this and put it right there, right? So to do that, we know that we have an imperial radius here, right? So we want to go by this, and then let's just do +0 for now. And then where we had that 4 hard-coded, that's the circle up amount, right? F4. Okay, so now, right, this circle is kind of like right here. And what I'm noticing is no matter what we do, trying to make a divider, right, like chop it off from here at the very top, we're never going to be able to get something satisfactory where we get a nice, we can't get a nice shallow curve and cut it off at the top like this, right? Because as this curve gets more and more shallow, it becomes closer and closer to a horizontal line, which means that this horizontal line we're trying to use to cut this shape in half isn't going to work very well, right? I don't know if that explanation made any sense, but I'm starting to witness that. So let's try to just get the curve where we think it should be, or where it looks kind of good, and then we'll worry about the... I like, see how this line right here is here? It'd be nice just to move it up so that those kind of tangent each other. I don't know, just because I like happy coincidences, right? So 2.2, how about 2.5, right? And just try to get it, and this is the... Oh, hold on. Wrong thing. F4. So I'm trying to get this part to go right up here, hit that, right? Or actually, trying to get this curve. I'm trying to get this curve to look like it belongs right here. I mean, obviously, it kind of already does look like that, though, doesn't it? Because kind of already does. Let's go look at some of our other things that we already drew. Right, so if you look at the Taurus for a second. Not that one. If you look at the Taurus, we don't want to make this symbol too small, right? We want to... okay, so right here, if this is the line we're crossing, right? I think we want it a little bit, even though it would be nice to kind of line up with this line. If we line up with that line and that line, it's going to be between here and here. It's actually going to be a little bit small, I think, in terms of the relative size compared to the other astrological symbols, right? So if we look at this, Or not that, sorry. If we look at this rendition, and also the Gemini symbol seems to be kind of tall, right? So yeah, we want to try to maximize the area. And if we try to make a happy coincidence with here, it's going to end up a little bit too small. So this up amount, let's add a 2 on that. Let's make that a 2 for a second and go F4. And now it's like in this deleted area. So let's try like a 1.5 F4. Okay. Yeah, and then we could delete it from here. So we got like a very subtle curve. I'm not sure if I'm really happy with that curve, though. I feel like it needs a little bit more curvature. And because we've chopped off so much of it, it's not all there. So if we look at the imperial radius here, we have an 8. Let's change that to like a 7 for a second. F4. 7. How about a 6? How about a 5? Right. So now if we chopped it off here, we could just, right? Now if we do that enough, we can get it so, so we could have like a nice little chamfer. So like if we try something like 3, let's go kind of drastic here, right? If we do that, then we can keep this kind of straight line here, and we can just chop off the point, right? And I don't know if that's going to be the best way to do it, but then we have a lot of stuff that fits here. So we got the slight curve, but we also have, I feel like chopping it off at an angle might make the most sense. I don't know. We'll think about it as we're kind of like doing this. But yeah, I do kind of like that. Part of me says that, you know, we shouldn't even chop it off like that, or we should just use like an angled. We should make the line kind of, we can chop it off kind of like, tangent, right? Chop it off in a tangent manner. And to do that, this right here, instead of using a difference, well, we still want a difference, but we don't actually want it in here. I'm going to change my mind on this. So here's this circle, right? So we want like a difference operator in here. And we want, this is the geometry we want to write, but then we want to subtract like a polygon that kind of emanates from the center, right? And if we subtract a polygon that emanates from the center, then we can chop it off with a, it'll always be chopped off with a line that is perpendicular. So if we do like polygon, okay, points equals this, and then we'll put a list of these points have to be in terms of native units. So we already did a polygon earlier, right? And we needed a thing called impnat. So we need this thing to convert to native units. So let's steal that. And then here's where we want to do this other polygon. Let's just put this here, right? Conversions. And within here, we're going to say, well, the first one we're going to do is just 0, 0, like a little origin. And then the next one we're going to do is, we need some type of distance, right? So, pi dist, right? DST. And that's going to be like the, what do I have on my clipboard that's making me wonder here? So that just needs to be like this imperial radius, right? This imperial radius for the imperial's thickness thing. This rectangle span could actually do it. But let's not use the rectangle thing. I just want to delete. So let's just copy the values for it. Make sure we haven't introduced any Exactly. Make sure we haven't introduced any syntax errors because we're really good at that. And look at why we have a syntax error. It's because of this, right? So I don't know what's going to happen there, but I don't know where I'm screwing up here. So let's so at some point we did something stupid with like parentheses, who knows what. This looks kind of wrong, right? We have an extra parenthesis here. Okay, save that. Okay, F5, F4. Okay. So now let's go back to these polygon points, right? And 0, 0, and then we have this pi distance. And we're going to do something like do some trigonometry, right? So let's do trigonometry stuff and do like cos, some type of angle, probably like, okay, 180 is like over here, so 0, 90, 180, so we want like 270, I think it's 270, 270 minus ang delta equals like 15 maybe. Angle delta and minus ang delta times the distance, so this distance here. And then the next thing will be sine of 270 plus the angle delta times pi distance, dst. And we want to do the same thing multiple times. So we have, you know, this entry, and then we want to create like a triangle, right? So then this thing here, we screwed that up. So this needs to be, these both need to be minus, and then these need to be plus, right? Because these are 3 points on a triangle, right? And this isn't going to work quite yet because we forgot that all these calculations are using the wrong units. So let's just do this, F4, make sure that there's no syntax mistakes, and you see there's nothing getting deleted here, right? That is as to be expected because we need to scale everything correctly. I don't have to worry about scaling the 0 does not matter, because 0 being scaled doesn't, if you add a scale to 0, it's still 0, right? So let's add the scale, right? And now oh, there we go. We got a little cut. Now, we actually don't want a difference. We actually want an intersection. Intersection. Do F4, right? So we want the inverse of that. And then just widen it a bit, right? So this delta, right? Let's widen that to 30 degrees, right? F4. If we widen that to 30 degrees, that looks a little bit better, right? Now it's a little bit close to the top. I do like the amount of curvature, though. Like, the amount of curvature is kind of nice. It's not too steep, but not too bad. So the next question is, well, what do we got to fix to put that where it needs to be? So we have this thing called circle up, right? And all this code seems to be encompassed within this circle up code. So I think all we got to do is change this to like a 1.3 maybe, F4. Right, a little bit lower. And, right, so we said not quite, we don't want it quite aligned with this line because it would make the symbol too small. So the more drastic this curve gets, the less space it can take up. But that's a pretty good proportion, I think, there. And the next thing we want to do is we just want to mirror this vertically, right? So this code right here, we just want to go here and go MV for mirror vertically, because it's completely centered, and then we'll get the bottom curve, right? F4, bam, bottom curve, right? Now I just got to draw 2 lines between there, and then we're good, right? So let's give that a shot. 2 lines. So how are we going to draw these 2 lines? Well, we should think about where is the placement of... Where is the surface of this curve? How do we find the surface of that curve, right? And, well, first of all, what's the radius of that circle, right? And where is that circle being drawn? So this circle is being drawn here, right? And so this is the circle up, right? So this is the amount up we're moving the circle, and this is just the radius. So if we want that point on the circle, then we just need to so we kind of already have that math, right? Because, but what I would like to do is this intersection, I would like to put this translation only in here, and then add the translation manually here, so that the formula just works better. Or not works better, but, so the base angle angle B equals 270 minus ang del. Or A1. Angle 2 equals, 270 plus the angle delta. Right? Okay, let's make sure I didn't make any syntax errors. Okay, so let's I want to just make this kind of smaller, right? So this thing here, bam. And this right here is a plus, and it's angle 2, right? Okay, let's run that again. F4. Okay, still there. So cos A1, whatever. So this distance, let's just call it PD. And PD will just be pi dist, right? Pi dist. PD equals pi dist. Right, so we can keep the original kind of name here in case we forget what we're doing. Right, and we're just trying to keep this more shorthand, so we can... so this thing, IN, imp nat. And there is a reason to this, to why we're making this kind of short and more obfuscated. So we want to add an offset to this. We want to translate it. We only want to translate it on the y. So for now, let's do +0 and +0 here. No translation, right? But we're setting it up for translation. And now this this y code right here, this thing here, we're gonna put it in here, right? And things aren't gonna quite look correct once you do this because we're extracting the translation and only applying it to we're applying it to the geometry but not to the subtraction, right? So everything's gonna it's not there anymore, right? To fix that, we just have to say, okay, well, what's this offset here? Okay, this is a positive offset, and it's on the y. Okay, well, let's add that offset, right? And we also would need to add that offset to the y on this as well. So I almost screwed that up. Okay. So now... Oh, we're screwed? We're still screwed? Well, this says y. This is an inch y offset. Oh, yeah. So this, that's wrong. So the offset we need to apply, right? So you see this conversion here, right? Where we do all this stuff. That conversion needs to happen. That needs to be the very last thing that happens after the translation as well. So we do plus this circle up, right? Plus the circle up, or actually plus 0, right? We're not doing it on, it's not a translation on the X, right? It's only a translation on the Y, right? So these formulas are still the same. And then circle up times the conversion. Okay, now let's try that. Let's try that. Now, there we go. So now we have the original. But why was this important? Why was it important to extract this translation out of there? Well, it's because now we have a nice formula that is kind of telling us exactly where the origin, right? Here's the center point. This is the center point of that circle, right? In native units. And then these lines here, we know they're translated the same out, but then they go the distance, they go the imperial radius. So we can take these formulas, instead of going by the imperial radius with a little offset, we can go by exactly the imperial radius and we'll be on the line. We'll be like right there. So here's what we're going to do. So we're going to steal these now, right? We're going to steal those, and we could actually just keep it in here for now. And with these formulas kind of stolen, we can... let me think about this for a second. We can start to create I don't know if that was the best way. I think we're making this too complicated, right? All we need to do is, like, just eyeball it, right? Like, why do we need to do it? Why do we need to be that fancy, right? We just need to make some vertical lines. And just roughly gauge it where they need to be. I mean, it's not like we're going to ever remake this code. Why the heck does it keep on changing my title to UI frags? Like, every time I go this... we're on video number, what is it, 187, and we're working on the Gemini, so, Gemini, okay, so, yeah, maybe we're just making this way harder than it needs to be. We're not trying to, like, spend forever on this, right? So, let's not do that. Let's save this. Let's go F4 for a second, and let's not even worry about that, right? Let's just throw some stuff in here and just get it to work, right? We don't got to worry about that. We just got to go like a, you know, we need a V-carve inch pocket, so it's a pocket shape, which is a rectangle, but and we just need to do something like, you know, maybe it's like. The thickness needs to be... We should just make the thickness the thickness of the Zodiac sign, right? So the width is going to be this, and then the height is going to be like, I don't know, 4 inches maybe? And the thickness variable is actually going to be 0, because I don't want to use thickness. I know that's kind of weird to say the thickness is 0, but we use it here. But maybe thickness was a mistake when I decided to add it as a parameter, right? So we just want to position that roughly where it belongs, and we shouldn't need this is shallow enough that if we put it right in here, it'll be fine, right? So let's not worry about that. Let's just say, you know, we want to translate it by inch x and do, like, you know, 0 SBC and then 0 minus 1, right? Just throw something in there, see if that looks correct, and then adjust it as we go, right? So a little bit too far, so maybe like 0.8, right? 80-20 rule. I know I'm kind of being kind of superstitious. That's not enough. 0.5, let's go halfway. F4. That might be okay. That might be okay. Maybe a little bit more, maybe a little less. Make this a 3. Let's try to get it exactly into place, right? Okay, good enough, right? So we have this, and then all we got to do is mirror it horizontally, right? So we just got to go, hey, mirror that horizontally, and then you're done, right? Instead of all that complicated math I was about to do. Now that kind of complicated math I was about to do would make sense if we were going to try to readjust this all the time, but we're really not. And that actually is nice, right? Because we have this kind of, this thickness in here, it directly matches the line thickness, which actually I kind of like, right? That looks pretty good. So we might want to codify this thickness in the middle. So rather than using this hard-coded value for the, not for that, the mirroring, how do we get it over here like that? The inch X, yeah, a lot of happy coincidences happen to make that happen. Let's not worry about it, you know? It's there. I like the proportionality where this kind of matches that. It's, yeah, I think that works. Yeah, that works. I think that looks good. I'm happy with that. Good enough. Good enough. So let's move on. Right? Let's move on, because that's good enough. So here's the Gemini code. First thing we're going to do is we're going to just remove these things that were helping us to visualize what was going on. Save it. F4, everything's not going to show up anymore. Close this one. We're going to go up into here, and we're going to open up like one of these. Open with Notepad++. We're going to copy this and just use this to start our other stuff. So new, and we're on Gemini, right? So this is Gemini 01, right? And it's just going to call Gemini 01, right? So this is going to be called, in the cut folder, it's literally going to be called Gemini 001.scad. And then we're going to make another file, right? So the idea is that if we want to figure out where a Gemini 01.svg vector file is coming from, we notice, oh wait, there's a source file with that exact same name, and then within that source file, oh, there's a function with the exact same name. So the reason we're adding kind of more files than maybe necessary is to make it really easy to connect those dots, because a lot of times one of the hardest challenges is just connecting those dots in your code, where it's like, yeah, I see, right? We don't want connecting the dots to rely on some type of tribal knowledge. We want to codify it so that if we have amnesia today and then tomorrow we totally forget, we can still make things happen here. Okay, so now that we have these, we're just going to open them up, and if we've done everything correctly, we'll just be in good standing, right? So F4, and then we're going to zoom extents, and yeah, there we go. So render that, and then file, export, and we're going to export as a SVG, and this is gem001.svg. Okay, so now the next thing, which is kind of like, it's kind of repetitive where it doesn't really matter, but it might matter in the future, and that's kind of why we're doing this. So if we zoom extents, right, the next cutting path for this is just locator holes, right? You notice that all the cutting path locator holes are all identical. That is intentional, because we want to make these interchangeable tabletops where they all have the same pins in the bottom for fitting the table to the frame. So file, export as SVG, and we'll call this gem002.svg. Okay, save that. Okay, cool. So we have the stuff, right? We have the new kind of thing here, right? Pretty cool. And what I would like to do, I would like to kind of make maybe like a little slideshow of what we have so far. So here's what I'm thinking. I'm thinking let's open up what we have, what we've been working on, and let's just screenshot some of these things, right? And I don't want to screenshot the whole everything around it. I just want to screenshot the symbol, right? Because I don't really care about anything else but the symbol. Okay. And we'll save that as UPAT folder. And we'll go back, and we're going to go SB Shopbot models, so SBM. Or no? Oh, no. Models Shopbot, got it. And the Zodiac table, and then right here, we're just going to call this, this was the Taurus? No, it's not Taurus, it's Aries. Aries.png, right? And then we'll kind of do that for the other ones, right? The other ones that we've already kind of made. So we have the Aries, and then we have the Taurus. So let's go here. And let's just do the same thing. Let's just snip this. And this isn't meant to make an image that we're going to like put up on the internet for other people to look at. This is just so that when we come back to this code, or this folder, project folder, in like a year or a few months even, we can just flip through the gallery really quick and see what we're doing, or see what we did, right? Same thing with this, right? So we can go over here, and we can snip this as well. So snip. Okay. And this was Gemini. Okay. So if you, and that's so we have the easy way to reference things. If the code breaks, we can still look at the PNGs to know what it should have been. Hey, how's it going? So today I can show you what I got. I just took some screenshots, so I can show you what I'm up to here. So I am desperately trying to figure out how to make money on Etsy before my money runs out. So I'm taking my last $1,000 and trying to figure this out. So I'm making some paths to, I'm like, what do people like? What do people like that I can sell, right? And so I'm thinking, I'm working on like these symbols, right? These Zodiac symbols. And I'm going to make table designs that have these Zodiac symbols in them, right? So right now this is Aries, this is Gemini, and this is Taurus, right? So I looked at the different Gemini symbols, tried to stylize them. The really hard part here is I'm not doing this in a vector drawing program, so I have to like draw all these symbols using just primitives and math. Good for me that a lot of these kind of symbols are very geometric, so it's very easy to kind of get this working. So the next part is just going through these one at a time and just creating all of them. And then I'm not going to make a table with all the symbols on it. I decided that what I'm going to do, if we go into, let's close this for a second. Let's go open up this. This is the main file with all the stuff in it. And let's go into the code here. And let's just take one of these and take actually, maybe I changed my mind. Let's close this. Let's go open up this. Oh, you know what? I already have SVGs. What am I doing? I don't even have to show you. I don't even have to show you the code. I can just show you the actual renderings, right? So, okay. So here's the table design for the Aries, right? So the idea is that well, I mean, right, so just like a square table, but then I'm going to make this like a glowing epoxy, right? So the white part you see is going to be like a glowing epoxy, right? And then pretty much the same for every other table, right? So it's the same kind of simple circular design, and then we just have a different symbol in the middle, right? And then Taurus, right? So what I've been doing is I've just been taking a break after each one of these. So after I get one done, I just stop the stream and I start another one later. And I started with Aries because I was looking at Google Trends, and there's definitely like a trend where depending on the month, whatever symbol is most associated with that month is more prominent on Google Trends when you look up the symbols. So I'm thinking, okay, well, if somebody's going to come to the shop, which Zodiac symbol are they going to want to buy? Well, if they're trying to buy a present or something for somebody, they're going to look up their specific Zodiac symbol. So the idea is to keep this kind of like stylized kind of thing going here. And also it's less work, right? Because to make one table, I only had to figure out one symbol, right? So I want to get something, I want to get stuff ready for the shop bot, right? And I want to keep it a little bit simple just because I want to figure out my workflow, my process and whatnot, and how to refine it. And I'm thinking, there's this analogy where people talk about pottery, and two groups of people working on pottery, and one group was like, hey, you have to just make one piece of pottery, but it has to be awesome, and however good that pottery is, that's going to be your grade for this class, right? And then there's another group of people in this class, and they're like graded on, okay, you just got to make a lot of pottery, and you got to make like one pot every day, and the average quality of all those is going to be, your final grade, right? And so, for whatever reason, well, I think I know the reason, but the group that had to just mass produce pottery, actually their quality ended up being better than the quality of the group that had to just do one pot and make it perfect. So I'm thinking that that's a pretty good analogy for how things need to be done, where the more iteration, the more practice you get, the better things become. So if I figure out a way to just get a product out the door very quickly, then I have more ability to iterate and refine my process and all that good stuff. So that's kind of where I'm going with this. So that's ready. We're going to do a git bash here, and we're going to see if this index refresh thing is still doing cd dot dot, cd dot dot. Okay, so git status. And last time I did this, it was like refreshing the index for forever, and oh no, it didn't do it that time. Okay, git add dot, or was it after the git add? I don't know. Something about my version control has started to become very slow, and I think it's because I added paint.net files in here, and I regret doing that. So I regret adding, maybe I shouldn't have never done that. It seems to have happened after that. Okay, so, because git status, because I believe my photos repo that has paint.net files in it also does that. Like large binary files, I don't think are very good for git. Okay, so git commit -am, and we just finished the Gemini. Gemini finished. Okay, so we finished that design. And git status. Git push GitHub. Okay, we're going to push that to GitHub, and then the next thing looks like Cancer, I think. We're just going through them in order. Cancer will be not too challenging. The challenging part is going to make sure that we have a tangency between the circles and the curves here, using nothing but circles. And I think I can pull that off. I just gotta... yeah, I'll have to think about how I'm going to do that. Like, I'm looking at, like, the reference I'm looking at right now. I mean, most of the things I've looked at are pretty much the same, right? There's slight variations, right? So, like, Cancer, Zodiac, symbol, right? So if we look at this image, it's a crab. Is that really a crab? Is that supposed to be a crab? Interesting. Didn't know. Oh, those are fancy. But right, like this is probably what we're gonna go for, right? So this is kind of looking at this, we can kind of see that it's not quite to the quality I would like, though. The missing part of the quality here is I can tell that there's a tangent. Maybe I'm imagining it. No, maybe I'm just imagining it. No, maybe it's okay. I just thought there might be a tangency problem here. Actually, maybe that is the quality I want. Maybe this is what I'm looking for. Maybe this is the kind of design I want to make. Yeah, so kind of circle that, right? That's the two kind of, right, the primitives that you need to put together to create that. But yeah, we want to do it kind of in a very mathematical kind of a way. And yeah, so we could have it really branched out like this. Yeah, you could do a lot of things like that. But we're going to try to do it in a way where it would be kind of nice if it was a circle and a circle, right? That would actually make it a lot easier, right? So if we're thinking about how everything needs to be put together for the 69, you have a big circle, right? And then you put these circles tangent to each other at a certain degree offset, and then you're good, right? Circle and a circle. Right, so the idea is to figure out the underlying structure. So this looks like an ellipse here, slightly elliptical. But yeah, if we do a circle and a circle, right, so two circles, two smaller circles and a bigger circle, and then some of the geometry is cut away, right? If we think of it that way, it's actually quite easy to do. Okay, it's good that I took some time to think about it. Now, I don't see anybody who's actually doing it that way, or maybe I'm just not being able to visualize it, because this doesn't look like a perfect circle. Right, but you can see like this kind of makes a circle, and these are, yeah, so yeah, that's the way. Oh wait, no, somebody figured that. No, right, this is not a perfect, these are not three circles, right? So the idea is I'm going to make it as three circles. Now the question is, maybe that's the wrong way. Maybe people intentionally aren't making it a circle, because look at this crab silhouette, right? Crab is not a perfectly circle-y thing, right? Right, so maybe this ellipse is intentional, right? Right, it's intentionally elliptical. You could definitely argue that there's an intentional elliptical structure here. But even if you were to argue that, is it not stylizable to that point? Is that not within the realm of acceptable stylization? Like, look at this, right? This is kind of squashed in the other direction, right? Instead of being compressed along the y-axis, is being compressed along the x-axis, right? It's taller than it is wide. Whereas this is more wide than it is tall over here, right? This is wider, this is taller, right? This is kind of more circular-ish, but not a perfect circle in the middle. Yeah, so I think you could get away with a perfect circle and have that be acceptable. So the thing is to just look at some of the symbols, because sometimes if you don't know, like if you've ever looked at a stylized word in a language you didn't know very well, you might have absolutely no clue what it is, because you don't know what is embellishment and what is actually an important detail. Right? Like if we look like a stylized kanji logo, right? So let's look for like a stylized kanji logo. Okay, well that's obviously fire, but like okay, this is just logos that incorporate kanji. Okay. So, but well, actually, this is a good example, because if I understood kanji well enough, I would know what logo they're what kanji is this based on? What's the derivative there, right? And I don't really know. It kind of looks like city, but I could be wrong. Like this stylization here, like you see this kind of square thing, and you're like, oh, is that supposed to be a square, or is it supposed to be circular normally, right? I don't see any really good examples, though. But I've definitely seen like weird stylizations where I'm like not sure what I'm looking at anymore because it's so embellished. But I don't actually. Oh, that's actually a good example. Well, no. Yeah, I mean I think that's a good example. Well, I can still kind of tell, but you see how this makes it, if you're not very familiar with kanji, how this could be very difficult to know what shapes you're looking at here, because they made the lines they're super thick black lines right there. Or the cursive versions of the kanji are kind of harder to look at. But yeah, so the idea is that when you're trying to stylize a zodiac symbol, you got to make sure you understand what it's supposed to look like, and you don't want to embellish it too much or distort it too much to where somebody doesn't know what symbol they're looking at anymore. Okay. So, do we just want to do the Cancer symbol now, or not, or do we want to do that later? I think I want to do it later. I want to take a break. And also, I set this with Zodiac table Gemini, and so the next time I start up a stream, I would like that to be the next symbol, right? So we'll do a circle within a circle, and that'll be it. So I'm going to stop the stream, and then I will be back later to do the next symbol.